A year's physics. We're doing kinematics, and today I want to show you from home using very crude equipment how we can measure the acceleration due to gravity. How are we going to do this? I'm going to throw myself off a really high cliff with a stopwatch. We're going to measure, no, we're not going to do that. I'm going to measure a height of 2 meters, and then I'm going to drop an object, otherwise known as this blue pen, from that object, and I'm going to measure the time it takes using my really fancy time measuring device called my phone. I'm going to measure the time. Maybe I'll do it 5 times just to try and increase the accuracy just a little. And then we're going to use a Suvat equation to calculate acceleration due to gravity. If it is accurate, I will be absolutely amazed and you will be impressed. If it's done badly, you will excuse me, because all I'm using is a phone and a measuring tape and in very crude instrumentation. So, pop the phone down. 2 meters. Let's measure 2 meters. I'm measuring from the floor upwards, and 2 meters is just here. If you can see it, it's just below this piece of trim on my wall. Now, if you can't see that, take my word for it. So I'm going to drop an object, this pen, from that height. Maybe I'll do it 3 times. I'm going to find my stopwatch and I'm going to measure the time taken. Alright, here we go. 3, 2, 1, drop. 0.59. Measuring the time in seconds. 0.59. I think I'll do this 3 times. Let's do it again. I'm quite possibly more than a few millimeters out. 3, 2, 1, drop. 0.66. I'll do it one more time. No injuries yet. Okay. 3, 2, 1, go. Ooh, I was a wee bit slow that time. 0.72. 0.72. Okay. So let's just add those up and see what we get. So 0.59 plus 0.66 plus 0.72. That's a lot of variation, which just goes to show this is not a very accurate way of doing this. Gives me a total which I divide by 3 and I get 0.66. 0.66. So I'm going to write down some data now. If this comes out really good, I'm amazed. So the time we're going to use is 0.66 seconds. The distance we're going to use, this S is for distance, this S is a unit, it's seconds. Don't get confused. S is 2.00 meters. So it's accurate to the nearest centimetre. Now that's being generous. U is 0 because I'm dropping it from a stationary point. It's not moving at the moment I drop it. V, I do not know. A, I do not know, but I want to find out. So what Suvat equation do I use? Let's just go through. What have we got? We've got S equals U plus V over 2 times T. Great equation, but we don't know V, we don't know T. There's 2 unknowns, cannot use that one. There's V equals U plus A times T. Again, don't know V, don't know A. Want to find out 2 variables, cannot use that one. 2AS equals V squared minus U squared. You need to memorize these equations. 2AS equals V squared minus U squared. Well, A is what you're trying to find out. V you don't know, can't use that one, which leaves S equals UT plus half A T squared. Can we use this one? Well, of course we can. We've run out otherwise. S we know, U we know, T we've measured, A we want to find out. One unknown. We can use an equation to solve to get one unknown, to find one unknown. So let's just write this out again. So S equals UT plus half. Now the acceleration we are trying to find is G. So I'm going to call it G. T squared. U is 0. So this term disappears. S equals half G T squared. So G will simply equal 2S over T squared. Can we do this? Yes, we can. So G equals 2 times 2.00, which is just 4, but I'll call it 4.00 just because I feel like it. Time is 0.66 squared. Now I'm not doing that in my head, but if we do 4 divided by 0.66 squared, we get an answer of 9.2 meters per second per second. That is what we find G to be. What could we have done better in our experimental technique? Pretty much everything. We could have measured height a lot more accurately, but we could have synchronized the dropping and the timing of the release point and the point at which it hits the ground a lot more accurately by using a light gate. Do I have a light gate at home with me? No, I don't. Do you have one at your place? No, you don't. So you can try doing it the way I did it, try and get a more accurate result. I could have measured the height a lot more accurately, but I just wanted to do it roughly to see what we'd get. 9.2, you could perhaps say, oh, there's a bit of air friction and that could have influenced things. Not really very much. We should be able to get 9.7, 9.8, 9.7 or 9.8 really. But for a crude little experiment, great. The other thing I wanted you to learn was selecting the right Suvat equation. Very, very important. So, go back, try and do this at home, do the rest of the questions in the book.